Hello everyone, I'm Matt Kutra and my partner for this project is Jack Kim, and this is a tutorial on lesson 2.5, Implicit Differentiation. So previously, we've been deriving equations in explicit form, such as y equals 3x squared plus 6x plus 7. And when taking dy dx, you would simply you would get the equation y prime is equal to 6x plus 6. Now, we're coming across a new topic where you receive the equation in implicit form, which would look a little bit like x squared minus 2y cubed plus 4y equals 2. Now what you would try and do is set this in explicit form where it would be as y equals with respect to x, but in this equation it would be a complete pain to solve for y, so we have to do implicit differentiation.
Hi, I'm Jack, and I'm going to show you a few examples of implicit differentiation. So when you differentiate terms involving x alone, you can differentiate as usual. But when you differentiate terms involving y, you must apply chain rule because you're assuming that y is defined implicitly as a differentiable function of x. So, for example, the first one is d dx x cubed. So simply it's just gonna be 3x squared. And for the next one, it's gonna be d dx y cubed. So you're just gonna do it. You're gonna have 3y squared, and you have to write dy dx. So we can do this for product rule or quotient rule. So for this one, we have d dx x squared y cubed. So by using our product rule, you're gonna have y cubed times 2x plus y squared times 3y squared dy dx. And if you simplify this, you're gonna end up with 2x y cubed plus 3x squared y squared dy dx. And you can do it for the quotient rule. So we have d dx of x over y. So by using quotient rule, you're gonna have y times 1, you can write it, and minus x times dy dx. And then all over the bottom, which is y squared. So if you simplify this, you're gonna have y minus x times dy dx all over y squared.
Okay, now we're going to be solving some equations in terms of dy dx. So these guidelines are in the book that you guys have. These are the key things that you want to think about when you're finding dy dx or solving for dy dx. First, you want to take the derivative of both sides with respect to x, including having the dy dx terms in there. And what you're going to want to do is you're going to want to isolate the dy dx terms on one side of the equation. So all of your variables on one side and all of your dx variables on the other, basically just basic algebra. And lastly, you want to factor and solve for dy dx so you're completely isolated to get your y prime equation. And now I'll give you an example of that. So say you had the equation 2y equals x squared plus sine y. Okay, so now what you're going to going to want to do is you're going to derive it and try and isolate dy dx. So on this side, you're going to have 2. When you differentiate with respect to y, it's going to end up being 2 dy dx equals, this is like normal, 2x plus, and then the derivative of sine is cosine. So you're going to have cosine y, but it's with respect to y, so you got to write dy dx on the end. Next, you're gonna, the second step, you're going to put all of your dy dx terms on the same side. So I'm going to move 2x over to this side and 2 over to this side. So I will have cosine y dy dx minus 2 dy dx equals negative 2x. Now what you're going to do is you're going to factor out the dy dx and divide on both sides. So cosine y minus 2 all times dy dx equals negative 2x. And finally, to isolate dy dx, you're going to divide by cosine y minus 2 on both sides. So your final equation will look like dy dx equals negative 2x over cosine y minus 2. And here's your final answer. So I'll give you a second to look over the equation, and or you can pause the video at this time.
Hi, I'm back, and I'm gonna show you how to find a slope of tangent line and the equation of it by using implicit differentiation. So I have the equation and the point, and so first you're gonna find dy dx, which is the slope of tangent line. So if you differentiate both sides with respect to x, you're gonna have 2x minus, and you have to use product rule for this one. So you're gonna have y plus x dy dx plus 2y dy dx equals 0 because it's constant. So you're gonna end up with 2x minus, make sure you distribute negative. So minus y minus x dy dx plus 2y dy dx equals 0. And you're going to move this to that side. So you're going to end up with minus x plus 2y dy dx equals negative 2x minus plus y. So you're going to divide that. And that's going to be dy dx. So you're going to plug that in to here. So you're going to end up with so that's going to be a slope of the tangent line. And you can use a point slope form, which is y minus y1 equals the slope and x minus point. So you're going to plug that in, and also this. So you're going to end up with y minus 2 equals the slope, x minus negative 1. So that's going to be y minus 2 equals 4 over 5x plus 4 over 5. So, and you're going to move that to that side. So you're going to add 2, and you're going to end up with this plus 14 over 5. So this is going to be the equation of the tangent line, and that's going to be the slope of tangent line.
Woo! Alright, so this is the last topic for our video, finding a double derivative. So implicitly, of course. It's going to be pretty much the same ordeal, except with a few minor changes. So let's go ahead and dive in. This is going to be example 7 in your book on page 145. but I'm not going to be using the point in it, so that part is going to be left out. But anyway, the equation is x squared plus y squared equals 25. So at this time you're probably a little pretty fresh on these, so I'll go a little faster. You're gonna get 2x plus 2y divided dx equals 0. And what you're gonna want to do, as usual, is solve for dy dx. So 2y divided dx equals negative 2x. Divide by 2y on both sides to get dy dx is equal to negative 2x over 2y, which equals negative x over y. Now, if you wanted to find the slope at that point, then you can plug in that the point that's given to you, but I'm just going to skip that for right now. Now, you have your dy dx, so you're going to take this and find the derivative of this. So, using quotient rule, I'm going to take out the negative because it makes it simpler for me, and I'm just going to leave the x over y. So the double derivative over, over dx squared is going to be equal to, take out the negative and put everything else in parentheses, y, times 1, but it doesn't really matter, minus x dy dx. This is all product rule, or quotient rule, over y squared. Now, the good thing is we can substitute in dy dx, which is actually one of my favorite parts of this because it's just fun for some reason. So, you come down, you'll get y minus, and then you're going to plug in negative x over y, so this becomes a plus, it becomes x squared over y, all over y squared. And now, if you want to check your answer with the book multiplies everything, top and bottom, by y. So the book will give you a final answer of equals negative y squared plus x squared all over y cubed. And there's your final answer. So I thank you for watching our tutorial, and I hope to help.
Yay!